Questions off the probability packet? Go ahead.
47.
Say it again.
47.
47. So looking at problem 47. Don't forget these other two packets at some point today. You don't have to do it right now, but at some point need to be turned in up there. A 5-piece band consists of a guitarist, bass player, trumpeter, saxophone player, and pianist. If there are 3 band members, if 3 of the band members each play a solo in an introduction to a song, how many different permutations of the 3 band members can be used? So, we know it's going to be permutations. If you don't have a calculator, grab one from back here real quick. Otherwise, get yours out. Remember, tomorrow on the test and Friday on the test, take your calculator with you.
Where's the permutation button?
All right? So on the calculators, again, the permutation buttons, if you have one of the, like the red, the TI-30 calculators, the permutation button should be, it says PRB, and if you push that button, it gives you permutations, combinations, then the factorial also, right? Yep. Does anybody else that has a different calculator that can't find it? Did everybody find the PRB button? So on that one, you go to math, then scroll over to PRB, and then down through there it says NPR, NCR. If you're looking that hard, you're looking at it, there you go. Well, this time we want the permutation ones. You don't push any of them, right? First thing we got to do is we got to figure out how many of these band people are we picking from?
5.
5. So that's the number that goes out front here. How many are we taking at a time?
3.
So it goes 5P3. All right? So on our calculator, we put in the 5 first. Then you go to the NPR, and then you put in 3.
60.
So how many different permutations are there?
60.
60 different ways that they could choose the 3 soloists to play. Permutation is, so if I have these, if these are my band members here, there's 5 of them here. I think, well,
Yeah, there's 5.
So there's 5 of them here. A permutation is, if I take 3 of them at a time, the different ways that I could pick those 3 out of the 5. Now, if I pick these 3, that's a different permutation than picking these 3. Because if I pick in this order, this one plays first maybe, this one plays second, this one plays third. If I pick in this order, this one picks first, this one picks second. Or this one plays first, this one plays second, this one plays third. That's a permutation. A combination would be if I took 3 of them, and let's say they were all 3 going to play at the same time. And I just picked these 3. Well, if they're all playing at the same time, it doesn't matter which order I picked them in. So that's a combination. Permutation is when maybe you don't want to play first because you're nervous about it. All right, you'd rather Johnny here play first so he screws up and then you don't look so bad. All right? But if it's a combination, then all 3 of you are just playing. So it doesn't matter which order you're in. Other questions on the packet?
30.
30?
30 and 31 confuse me.
Right.
After an hour, you do it.
30 and 31, both of them. First of all, I did this on my key because
I don't. Yeah,
What?
it doesn't show which one's yellow, which one's green.
you can't see the yellow and the green. All right, it used to be that you could, and then I ran this copy off so many times that now it's gone. So on that, let's just say there is no yellow and there is no green. All right. So what's the probability that we get a green, then less than 6? Well, what's the probability you get a green?
0.
0. So 0 out of how many?
6.
Eight.
Well,
8, isn't it?
6. Yeah. Good eight.
Right? Plus, ignore that. So there is no green on there, so you can't get a green. Because I messed up and didn't put the green on there like I was supposed to. What's it, how many numbers are less than 6? 5 of them? Is there 5 of them? So 5 out of how many?
5 out of 8.
And then we just add those two. What's 0 plus 5? 5. And then on bottom,
16ths.
now be careful. What do you do when you're, it's just 8, right? You don't add the bottoms. If you're multiplying, you multiply the bottoms. But if you're adding, it's saying 0 eighths plus 5 eighths gives you 5 eighths. That'd be your answer. What'd the answer of 31 be then?
3.
3 out of
3 out of 8.
3 out of 8.
I just didn't know. if
Yeah, that was my
any that
fault.
was specifically
You want
green
your
or
card
yellow.
questions?
Yep. Took me one.
Can we do 40?
32. 32, I'll come back to that here in a second, Mattis. 32, a card is drawn from a standard deck of 52 cards. Find the probability that the card is a club or an even number. So we want probability it's a club or even. How many times am I drawing from my deck of cards? I don't know what happened.
One.
Deck of cards here, but there it is. How many times am I drawing?
1.
1. So I want the probability that when I draw that card, it's a club or it's an even number. Well, the first thing I better figure out is how many of each thing there are in the deck. Anybody know how many clubs are in the deck?
13.
Now, even numbers, or even cards. What would the even cards be in a deck?
2, 4, 6, 8, 9.
So how many of those are there?
5 times
Now,
4.
there's 5, but there's
20 total.
4 suits, so 5 times 4, which is 20. So, what's the probability of drawing a club?
13 out of 52.
13 out of 52. Plus
20 out of
20 out of 52.
And then we would minus out of the clubs.
Here's where you gotta be
We're already
careful.
counting the clubs.
Because what cards did we count here and here?
The even clubs.
The 2.
The even clubs. So we counted them twice, and we don't want to count them twice. So we're going to have to subtract off. We counted, how many even clubs are there?
5.
Yeah, you're right, Michael. I'm thinking of the next problem. So there's 5 even clubs here. Well, we already counted here, so we want to subtract them off from here. So we subtract off 5 out of 52. Again, the bottom's going to stay the same. That doesn't change. What's 13 plus 20?
33.
Minus 5.
28.
Grab your calculators. You can use the ABC button or the ND button, or if you have the big calculator, you have to punch it in like it's a fraction. So you put in on yours. So let me explain the other calculator first. On the smaller calculators, you push 28, ABC button 52, and it's going to tell you on yours. You put in 28 divided by 52. Go to the math button. See where it says fraction, and then hit equals, and it'll tell you the fraction answer instead of the decimal answer. What's it tell you? 7/13. Next question. Which one did you say, Madison? 43.
Overall, I didn't know what the report
So pick one of them. Somebody help us out and explain to Madison how to do 44. 11 P 9.
We did
Type
the-
in 11 on your calculator. Type in 11 on your calculator, then you find what? The PRB button. That's on most of the calculators. On some of them it might be a little different, but wherever you need to go. You find it, Madison? PRB button? Yeah, it's a big number. Hey, did you find the PRB button?
Yes, it's,
Spells dog, doesn't it? PRB, doesn't that spell dog?
no.
It doesn't?
Picture.
Sorry, I got you off track here, my brain. I got quit.
No, I understand.
Did everybody find the PRB button? Then we want what? NPR, right? Small r. Then you put in 9, and what's it tell us?
1995840.
2 zeros? Thank you for reading it out that way. Everybody else usually tries to read it out as a number. If you're explaining it to me up here on the board, just read the numbers and then we'll figure it out once we get it written down. It's easier that way. Somebody pick one, 48 through 51.
Is that the answer?
That's the answer. That's how many different permutations there are.
50.
50?
52.
Well, I'll do it next. Problem 50. How do we punch this into our calculator? Do what?
You type in 3 first,
3,
and then you go to
then you go to the PRB button.
and then you go to the,
You want NCR this time instead of NPR, and you put in 0. Now, you got to use some common sense on some of these. If I got these 3 books here, and I want to know the different combinations of me picking 0 at a time,
1.
there's only one way I can not pick any, and that's by not picking any. So the answer here is 1. Now the one I should have put on here, let's try this on your calculator. 3P3. I know it's not one of the problems on there, but somebody help me out. What's 3P3? 6. Now try this. 3C3. It's 1. The reason, hopefully this will help you understand permutations and combinations. Forget these 2 books are even here. They don't count. I got these 3 books. Permutation says, I got these 3 books. How many different ways can I situate them on the shelf? All right? Well, this told us there's how many different ways we can situate them on the shelf. 6. Combination says, I got these 3 books. How many different ways can I pick all 3 of them? 1 way.
All 3.
If I pick all 3, I pick all 3. Doesn't matter if I pick this one first, this one first, this one first.
Still picking all 3.
You're just picking all 3 of them. So that's a combination. Permutation is when, how many different ways can I stack these books? That's a different permutation than that. And that's a different permutation than that. But if I'm doing combinations, I'm saying, all right, I'm going to pick 3 books out of this stack. What 3 books am I going to pick? Those 3, because there's only 3 there, so there's only one way I can do it. Other questions? Everybody,
I think someone said 50.
52? Oh, that's right, you guys did say that, didn't you? My fault. Gotta help me out every now and then, Tage. Remind me. 52. A deck of 26 alphabet cards. A through Z is shuffled and 2 cards are dealt. What's the probability that the cards are X and Y? So I got my deck of cards here. Pretend that they got letters on them instead of regular cards, all right? We want the probability that we get an X, then a Y. What's the probability that you're going to get an X out of these cards?
1 out of 26.
1 out of 26. Now, when we're doing both of these this time, we're not adding anymore because we're doing how many different draws from this deck?
2.
2. We're dealing out 2 cards. So this is our first probability. Then our second one, we're going to times.
1 out of 25. You're not
So
putting X
if
back.
that's my X card there, what's the chances I get a Y on that next draw?
1 out of 25.
1 out of 25.
Because you're not putting X back.
Because we're not putting that in back in. It didn't say replace. What's 1 times 1 on top?
1.
Now on bottom, this time we do multiply.
I got
650.
Grab your calculators. Will that reduce any?
No.
Put in 1 ABC button, 650.
It's 1 on top. It's not gonna
650.
Did Tate actually do it?
No, Tage wasn't doing it. He's looking at me like I was stupid.
Oh. That's fine. Look.
That won't reduce any because 1's on top, right?
I looked at the calculator with my life listen.
Other questions?
42. Wouldn't have done.
42.
Yeah,
That's their
it's
will
hard.
gonna reduce.
42. This one. There's several different ways I think you could do this problem, but the way that's probably the correct way to do it, we got all those letters there. So you're this farmer, and you're gonna write no trespassing somewhere, all right? So you buy all these letters, you throw them in the back of your truck and you drive home. And 3 of the letters blow out. And they want to know what's the probability that the 3 letters that blow out are S's. All 3 S's. What's the probability the first letter that blows out is an S?
1 out of 13.
Be careful.
Are we including no in it?
Yep. So there's 13 of them, you're correct there.
Would it be 3 out of 13?
3 out of 13 because there's 3 S's, right? So there's 3 chances that that first one that blows out is an S.
Oh, yeah.
Times, what's the chance if that first one blew out, so one of the S letters is laying back on the road somewhere, what's the probability that the second one that blows out is an S? 2 out of 12. Now there's another S laying back here on the road somewhere. What's the probability that the third one that blows out is the third S?
3 out of 11.
1 out of 11.
Sorry.
So on top, it's 3 times 2 times 1, which is 6.
And then we multiply the bottom ones.
Multiply all the bottoms.
1716.
1716. Will that reduce any? Use your ABC button. This time, Tage, it will work, right?
Yeah.
6 ABC button,
1 over
1716.
286.
1 out of 286?
Yep.
Now, we also talked about this a little bit last time. That might not make a whole lot of sense to anybody. You go home, you tell your parents, hey, if you buy these letters, and after you explain to them for a second, they're going to say, and you tell them the answer, yeah, there's a 1 out of 286 chance that all 3 S's are going to blow out. They're not really going to care. But what could we do to make it make more sense to your parents? Change it to a decimal. How do we change this to a decimal?
The, S
You could use the SD
Divide
button.
'em.
You could divide them. 1 divided by 286. Somebody do that for me. 0.0034. Anybody else get that?
Yeah.
Yeah, but it'd be 3, 5.
Yeah.
35.
Yeah, next number's 9.
All right. Now, you tell your parents that answer. It's still not gonna make any sense to them because usually you go out past 2 decimal places
So we could do
and
35%.
nobody understands it. So the other thing you could change it to is
0.30.
a percentage. Now be careful.
0.30.
When you change it to a percentage, how many places do you move the decimal?
2.
So what's it come out to be?
0.35.
0.35%. What does that mean?
Not even 1.
Not even 1% chance that the 3 letters that blow out are the 3 S's.
But it's 100% chance of it if it happened.
So there's not a 1%, even a 1% chance. It's not even half of a percent chance that the three letters that blow out is S's. He wants me to throw him out, doesn't he? All right, set that off to the side. Get out your notes. This is what goes in the blank at the top of the notes.
Yeah. You want us to turn this in, hold on to it?
Hang on to it for now. We'll come back to it.
I like me like this, but I'm
Appreciate it. I'm not sure why I appreciate it, because it should be the whole cube.
Which order?
What order does
Is
it
this the
go?
front?
Yeah, that's the front. And then the one that says worksheet at the very end is the third one, so.
I took a random guess.
What? Did you give me my notes back? Oh, is this one circles?
So the blank at the top, I know it doesn't look the same, says circles. Fill in these, we've already talked about these, so these shouldn't be anything real new. Formula for area of a circle. Pi times radius squared. What do you know about a diameter of a circle?
2 times the radius.
What's a diameter do in a circle?
It's the longest.
The longest chord goes from one edge of the circle to the other edge and goes through the center point. And diameter is always 2 times the radius. What's a radius do?
It comes from the center and goes up to the edge.
Center to the edge of the circle. Please be careful on one of the next slides coming up. There's going to be a formula that looks like this. 2 times radius times pi. Is that the same as that? No. Radius squared is not the same as multiplying the radius by 2. All right? So don't think that. Next thing, the equations of circles that we talked about a couple of classes ago. Equation of a circle.
Your pen.
So on the test tomorrow, if you see something that looks like this, and it asks you, what's the center of this circle? Anybody tell me where the center point of this circle is?
2, 4.
Look at what it says here. This number is the x coordinate of the center. This number is the y coordinate. What is it?
2, 4.
2, 4. It's that simple. All right? What if I change this and made that a plus there?
It'd be -4.
So then the center would be 2, -4. Regardless of which way that is, this number tells you what the radius is, but is the radius 36? No, the radius, that number is the radius squared. So what do you got to do to this number to find the radius? Take the square root. What's the square root of 36? So the radius of the circle would be 6. If they just give you a formula that looks like this, doesn't have all this extra stuff in it, then what do you know about the center point? It's a 0, 0. It's at the origin. All right? So hopefully they give you that, right? Because that's a whole lot easier. Not really. I mean, it's not like it's difficult either way. But circumference of a circle. Circumference is what in relationship to a circle? If I draw this circle, what's the circumference?
The outer edge.
Distance around it. So if I walked all the way around it from here to there, that's the circumference. 2 different formulas for circumference. One is diameter times pi, and the other is 2 times radius times pi. Why two different formulas?
In case you get one and not the other.
That's true. Are they any different? No, diameter, the D is the same as what?
The two are.
2R, the radius times 2, right? So these are the same formula, just one of them has this in it, one of them has just that in it. When we get to some of the stuff that we're going to do later today on the homework, and hopefully we'll get to it, my other class, we didn't get to it, but there's problems where you're going to be finding the circumference in the area. There is nothing wrong with writing an answer like this. And leaving your answer that way. Don't grab your calculator and change it to a decimal right away, because as soon as you change that pi to a decimal, you have to round it off. You leave it that way. Just like when we talked about some of the problems that we did.
Something times the square root of 2.
Right, and you had like 5 times the square root of 2, and everybody wants to grab their calculator right away and change it to a decimal. There's nothing wrong with leaving it that way. That's an exact answer instead of a rounded off answer. So a lot of the answers on the homework, the whole first page, I'm not going to throw a fit if your answer looks like this. And hopefully we'll get to that and we'll talk about it. An ellipse. What's different about an ellipse from a circle?
It's only a section of it. Or, well, it's a slice.
That's a sector. What's an ellipse look like in relation in comparison to a circle? Circle looks like this. What's an ellipse do? See, and everybody wants to say oval. Oval's not actually a shape, right? It's called an ellipse, but out in the real world, most of you probably call it a what? Oval. But it's not really an oval. So it's like a stretched circle, or a flattened circle, or however you want to call it. With an ellipse, what always happens, a circle has one radius, and wherever you draw that radius, they're all the same. But with an ellipse, we have two radius, or two radii. One short one, and one long one. Alright, so that's the only difference. So you're always going to have a short radius and a long radius. Why the formula is written this way on this one, I don't know. You can change it if you want. Instead of pi there, you could have used the pi symbol. So pi times radius 1 times radius 2. Nothing really hard about that. It's just taking pi, you just grab your calculator, and it's pi times the first radius times the second radius. The perimeter formula is a little tougher. Everybody grab your calculator. Make you walk, Chase. How long is this radius? Make up something for me.
6.
6, I heard. How long is this radius?
7.
I heard 8. So if those two radii are 6 and 8, we're going to plug into this formula. So it's 2 times pi times the square root of, what's radius 1?
8.
So 8 squared plus, what's radius 2? 6 squared divided by 2. Everybody plug that into a calculator and figure it out. Then we're going to talk about the 75 different answers that you get. So try it on your calculator right now, because if you're not trying it, if you're not trying it on your calculator, then you're not going to know if you're getting the right answer, the wrong answer, or if you're punching it in right or not.
With the decimal.
Yeah, you're going to get a decimal answer, and that's fine.
Wait. I think I just realized how to get the not decimal answer.
Yeah, you could do it without just hitting your pi button.
Yeah, just.
So, what did everybody get?
I got 56.8.
56.89. Anybody get something different?
I got 44.43.
44.43. You got 150.
0.8.
0.8. You got what?
26.89.
26.89. What'd you say, Madison?
I calculated it says 25.5.
25.51. Dallas doesn't even want to chime in here because he's thinking, boy, Ebersole's gonna make everybody look stupid because everybody got different answers. Now, what I want you to do is make sure you're listening to me right now, because when it comes test time tomorrow and Friday, and you're just punching in stuff to your calculator, thinking your calculator knows what you mean, does it? No. So, on this problem, this is what I want you to do. If you have something like this, punch in all of this on top right here, and just that, and hit equal. So clear your calculator and punch in 8 squared plus 6 squared.
Just
So everybody got 100.
Yeah.
Now hit divided by 2. What's that give you? Now do this. What do we still got to do to that 50?
Square root of
So take the square root of 50 and hit equals.
7.0.
Now you got that number in your calculator. It's right there. We could write it down, but it's in your calculator. All you got left to do is multiply it by 2 and pi. So now hit times 2, then times pi. And what's it give you?
44.42882.938.
So about 44.4.
Yeah.
Did everybody get that?
Yeah.
Did I
Don't put it all at once.
Exactly. Don't put it all in at once. Make sure. And then even if you do put it all in at once, go back and check it by not putting it all in at once and see if you get the same answer. When you get these big formulas like this, I think we talked about that with the distance formula, didn't we? Not putting it all in at once because your calculator doesn't know what you mean. Next, find this on your paper. Should be right there close. I think everything's in order, isn't it?
Yep.
Switch something up on my PowerPoint because it was out of order, but I hope I got it fixed. Listen. So we're going to talk about several of these rules about segments and circles, different segments and how they're related to different circles or to the circles. The first one here. If I have a circle, anybody remember what's this called in a circle? When you go from one side to the other, but not through the center.
Chord.
A chord, very good. If I have a chord in a circle and I draw a radius that goes through that chord, two different things could happen. If that radius bisects the chord, so if it splits it in half, it also has to form a right angle with it. No matter what, if it splits that chord in half, then it forms a right angle. The other thing, and probably the thing that maybe is a little more important out in the real world, if I have a chord and it's here, and I draw a radius going through that chord that forms a right angle, guess what it does to that chord every single time? It bisects. Now notice here, and this is going to happen a lot as we go through a bunch of these. How come I drew in a dotted line there?
Because it makes a triangle.
Because it makes a triangle. Not only does it make a triangle, but what special kind of triangle?
Right.
A right triangle. And with right triangles, we can use Pythagorean theorem, sine, cosine, tangent, all the stuff that we've been dealing with here lately. So it might be sometimes you just add that in. Is it all right to just add in an extra segment like that?
No. Oh,
Yeah, because first of all, in this circle, what's special about that segment right there? It is a what?
Hypotenuse.
That's true, it's a hypotenuse in the right triangle. What is it to the circle?
A radius.
It's a radius. Normally, when you're given a circle, what's the one thing they tell you about the circle? How long the radius is.
Okay.
Next one. Must be my old slides. Fill in what you need to fill in on this. Some of these, like this one, sort of common sense. If I tell you that these two chords are the same, so if this one's 12 centimeters, what's this one have to be?
12.
That chord cuts off this arc. And it's 72 degrees. What do you think this arc right here is?
72.
It's got to be 72 degrees. Just common sense, sort of, isn't it? If I take a circle and I cut off this part, and then I come over here and I measured that, let's say I cut off and it was 6 inches, and I came over here and I cut off 6 inches, what's going to always be true about those two arcs?
They're equal.
They're always going to be equal. Alright? If I take a circle and I do this, and we're going to have another math rule here in a minute that deals with this. If I have this chord and this chord, and I tell you that this is 60 degrees, and this is 60 degrees, what has to be true about these two chords? They have to be congruent. They have to be equal. Alright? So that's just one of the rules. This one's right there at the bottom. Sorry, no blanks this time. Josh, I'm watching in case your arm falls off, because this is one of the few times in like the last 6 months that I've made you write it.
It's for Keaton's complaint.
Right. Write
Yeah,
an
Marvin.
entire sentence. You can all blame it on Keaton, because he complained that last time. What was it? We had to write like 4 words or
Yeah,
something in it.
yep.
I can hear Keaton's brain gear turning. It's not English.
No, it really didn't have anything to do with you. What it had to do with is I've had this slide for a long time, and the computer will not let me erase things on it now, or put new things on it, so. It's all right, we're out
That's
of
his way
luck.
of saying it's your fault.
Yeah, it was my fault.
Actually, it's the computer's.
So this one says, if you have a circle,
Good. Yeah, it's good.
and I have a chord here and a chord here, and it doesn't matter where the chord's are at. If this chord is the same distance from the center as this chord, then guess what has to be true about these two chords?
They're congruent.
They're congruent. Now the other thing, if this is a right angle here, what's this do to that chord?
Bisects it.
It bisects it. And now all of a sudden, now we have this. What kind of triangle do we have right there?
Right
A
triangle.
right triangle. Not only is it a right triangle, but the hypotenuse in that right triangle is what to the circle?
Radius.
It's a radius. And that's all information that we know. Circles are great things, just like triangles, because once you know one thing, you know a whole bunch of stuff about it. Hey, are you picking your fingers? All right. Are you lying to me? All right.
What are you doing?
What am I doing? I'm picking my fingers.
Oh.
What if I'm picking my fingers, you're not allowed to pick yours at the same time, all right?
Makes it weird.
All right? Hayden, do we have a deal?
Maybe.
If I'm picking my fingers, you're not allowed to pick yours. So watch me before you start to pick yours and see if I'm picking mine.
You're not really picking.
Yes, I am.
Okay, good stop.
It's all recording.
That's right.
Good try. He'll have Maverick trim it
I
out.
didn't realize we were recording.
I'm looking for.
Makes me wish I was quarantined right now.
Be unemployed.
You can blame Keaton for that.
Thank you, I'll be here all week.
With this one, write this down on there. A regular polygon. What's true about a polygon if it's regular?
All sides and angles are congruent.
All sides congruent, all angles congruent. So make sure you write that in there, make sure you know that for the test. We talked about this formula back a few chapters ago. The sum of the interior angles, n minus 2 times 180. N stands for what again?
Number of sides.
Number of sides. How many sides does this shape have?
5.
So what's 5 minus 2 times 180? Somebody help me out.
540.
540, everybody agree with that? So all these angles in here add up to how much? 540. Not 360, the circle is 360, the angles add up to 540. Can we find each one of these angles? Take 540 and do what to it? Divide by 5. Somebody do that on your calculator.
108.
So this angle is 108 degrees. What's this angle up here?
108.
108. What's this angle?
108.
This angle?
108.
This angle?
108.
Now, you told me entire circle is how many degrees?
360.
360. How many arcs do we have here?
5.
There's 5 of them. What do we know about those 5 arcs?
They're all
If these
congruent.
chords are congruent.
They're all congruent.
They're all congruent to each other. So, couldn't we take 360 and divide by what?
5.
What's that give us?
I don't know.
Well, okay, we have to calculate for a reason.
72?
Okay, got it.
So, what's this arc? How many degrees?
72 degrees.
72 degrees. What's this arc?
72 degrees.
72. This one?
72. 72.
All the way around. All 5 of those are 72 degrees. Did they give us any numbers when we started this problem?
No.
No.
Not a one.
We're just that good.
They just told us that this polygon was
Debatable.
regular.
That's all we needed.
And that's all we needed to come up with all that stuff. What if I drew this in here? See how smart you guys really are. I'm not doing this with my other classes. I have that triangle there. What can you tell me about these 2 sides in that triangle? They're both radii, so they have to be congruent to each other.
Angle 72.
What do you think happens with this angle right here?
Bisect.
Bisect, isn't it? So what's 108 divided by 2?
54.
So that angle's 54.
That's
4C.
Previous, that angle's 54. This one's also gotta be 54. Could we find this angle?
Yeah.
72, everybody agree with that?
Yep.
Now, we could have found that angle being 72 because we had another rule a while back that said that if the vertex is at the center and this arc is 72, what's this angle? 72, they gotta be the same. So we could have done that, all kinds of stuff. What do you think's gonna be true about if I draw in that triangle?
59.
All the same things, right? Next triangle, so on, so on, so on. Fill in what you need to fill in on this one. Baseball wearing you out that much.
Yes.
Wish it was wearing my son out, but team is driving me nuts this year. No game yesterday, canceled it. So he gets home, or I get home. He gets home about 4:30.
Like convertible.
No game.
Convertible. Press the button.
Practice. 2 or 3 hours of practice, go in the gym, kick ground balls, something.
I don't know if they're allowed to use the gym anymore. If it's the bleachers.
We talked about this one earlier. If I have a diameter in a circle, and I use these 2 endpoints of that diameter to make an angle, what's always going to be true about that angle?
Right angle.
It's always going to be a right angle. So no matter how you draw it, you use this point and that point, it's always going to form a right angle. Half a circle is called a what?
Semicircle.
Semicircle, and that's what this says. So if you take an angle, if I have this semicircle, and I inscribe an angle in that semicircle, what's always going to be true about that angle?
It's gonna be
It's always going to be a right angle. And again, look at what we come up with. What do we have right here?
Another right triangle.
Another right triangle. Fill in what you need to fill in on this one. Now we're getting into this other stuff. Nothing really hard about these, they're pretty easy. Dallas, I haven't messed with you all day. You been awake? Man, I ain't been paying any attention.
Okay.
He's been
Thanks. On the ball day, I appreciate it. Now, the way I wrote this, I wrote it out for you over here in relationship to this picture. So this is segment CE, and we're going to take it times segment EB. If you're in a circle and you draw two chords in that circle, those two chords split each other up into how many segments? Four. All it's going to be is this part times this part has to equal this part times that part every time. So if I put this in here, this is 2, this is 4, this part over here, I don't know, what is it? 7? All right. Could we find that part right there?
Yeah.
14.
Tell me how to find it.
2 times 7, so that'd be
2 times 7 has to equal what?
14.
And then divide it.
Has to equal what?
Well, 4 times X.
4 times x. This is where you guys are going to mess up. Don't do this on the test tomorrow. Write something down. All right? Because you start, oh, this is easy. And then you come to one that maybe isn't so easy, and you get lost. So write it down. 2 times 7 is what?
14.
Now what? Divide by 4. What's x equal?
3.5.
So how long is that segment right there?
3.5.
Now my picture doesn't look like it because we didn't make up very good numbers probably, but
Well, it's not about the picture, it's about the numbers.
is this one next on your guys'?
Yep.
Yeah.
Also draw this in on your picture here. There should be a right angle right there. Does anybody remember what a tangent of a circle is?
It touches
Look, I
the.
should have never complimented him, should I? As soon as I compliment him, then he.
Maybe you should actually hit him with that. It might actually.
All right. What's a tangent of a circle? Is this a tangent?
No.
This is a secant, right?
It's on
Goes
the
through the
outside
circle.
edge.
Tangent touches the circle at one point.
That's it.
So if I have this tangent of this circle, and it's hard for me to hold it like this, but it touches it at that one point. If I go from the center of the circle, the center point of the circle,
Where it touches the tangent.
to the tangent and draw a segment from that center point to the tangent, that is always going to form a right angle, no matter where that tangent's at. Right? So if I move that tangent over here and I go from this center point
Still
to that
right
point,
angle.
this angle right here is always going to be a right angle. Right? And that's what this says. So we draw from the center point to the point of tangency. It's always going to form a right angle right there. And then I could, you see the dotted line again, I could draw this in,
Yeah, you go.
and what kind of triangle do I have?
A right.
A right triangle again. And not only is this a right triangle, what do you know about segment QC? It's what to the circle? It's a radius again.
We're getting a lot of right triangles. They're everywhere.
Next one, 2 tangents. Dallas, you still with us?
Yeah. I don't believe you.
I don't either. His hand's not moving, is it?
I can't see that. He's feeling.
Dallas is working real hard today.
And now he's just up here moving his hand, acting like he's right. Dallas, how's that gonna help you, man? If you're gonna act like you're gonna write, you might as well write it.
Which pen was upside down?
If I have two tangents of one circle, so it looks something like this. No matter how it is on that circle, if I could hold it, guess what's always true about the length of this segment and the length of this segment? They're always the same, no matter how you draw it, alright? So if I take any circle, and I draw a tangent going from here, and then another tangent going from that same point, these two segments are always going to be congruent, no matter how I draw it. Could be from some point right here, go to there, those two are always going to be the same. Now these last couple are a little tougher. I'm going to switch this up, write this in down here at the bottom. So the reason this one's a little tougher, notice these are secants. Remember secants? Just go through the circle. They come from the same point out here, but they go through the circle. A secant has a part that's outside the circle, then it has a part inside the circle. What we want is we want the part outside the circle and the entire thing. So the exterior part times the whole thing. So if I told you this part was 5 and the whole thing was 12, it's going to be 5 times 12. That's on one side. Then on the other side, it's this exterior part times the whole thing. Let's say we were trying to find the whole thing. That's our x. If this part out here is 4. So it's going to be 4 times x. What is 5 times 12?
60.
Divide both sides by 4. What's x end up being?
15.
15. So this whole thing is how long? 15. How long is this part from E to D?
11.
How'd you get that?
Took 4 away.
All right, 15 minus 4. Now a lot of times they'll go backwards, and instead of you find the whole thing, they'll say find this part, and you got to remember to go back and do that after you find the whole thing. But it's just this outside part times this whole thing, this outside part times that whole thing. A tangent and a secant. Same idea on this, only a tangent, does it have the whole thing? The whole thing is the exterior part, right? So all you do with the tangent is you take, and I'm going to rewrite it down here a different way, so it'll say the same thing. It's tangent. What's tangent squared mean?
Tangent times tangent.
Tangent times tangent. So it's just taking this outside part times itself, and then the exterior part times the whole thing. Let's say we were trying to find this tangent part here. So that's our x. Maybe this part out here is, I don't know, give me a number.
40.
This part in here is how much?
60.
How would we set this up? What's the tangent this time?
Tangent's x.
And what do we gotta do to it?
Times it by x.
Times it by x. What is
So
x times
x
x?
squared.
X squared. Now,
Equals 60 times 40.
be careful now.
40 times 60.
What's the exterior part? Exterior part,
40.
40. What do we want to multiply that by?
Oh, the whole.
The whole
So
thing, right?
Times 100.
Times 100.
Oh.
X squared stays the same. What's 40 times 100?
4,000.
Which one is it? I heard three different answers.
400,000.
3 zeros.
4.
3 zeros? Are you sure?
Yeah.
Yes, 'cause I see 3 zeros.
Now what do we do?
And then you square root both of them.
Take the square root.
I got 63.2.
So how long is this tangent segment?
63.2.
63.2.
Roughly.
So tangent times itself equals the exterior part times the whole thing. Don't forget, it's got to be the whole thing, not just the inside part.
You threw us all off with that one.
Next one, a circumscribed polygon. We talked about this already earlier when we dealt with circles, but now you know what's true about segment ED and segment EF here. They're always congruent, they're equal. What's true about these two segments? They're equal. What's true about these two segments? Equal. How about these two? Equal. So you'll know that about all of them, all right? Now, what that's going to lead us to is this next thing. Fill in what you need to fill in on that. So if I tell you that this segment, I don't know, let's say it's 7. This segment is 10. This segment is 8. Can we find the length of that segment? This tells us that AB, how long is AB?
7.
Plus DC, how long is DC?
8.
Should equal,
BC plus AD.
so that's X plus 10. What is 7 plus 8?
15.
How can we figure out what X is?
Take
It's
away
5.
Subtract 10, so X has to equal,
5.
so how long is this segment right here?
It's 5.
It's 5. These two sides added together have to equal those two sides added together every time. Tell me something you know in this picture.
The two radii are.
Those two are congruent, so let's mark them.
The 2 outer ones are
Diagonal lines.
tangent.
Those two are congruent.
Running.
Where? Here?
No. At S.
And?
At S.
So those two are right angles. So if I drew this in here, two right triangles. And not only do I have 2 right triangles, what do we know about these 2 triangles? They're congruent to each other. We know all that stuff about this.
It gives you the radius.
What would be true about these 2 angles?
They're congruent.
They'd have to be congruent. What's true about these 2 angles?
They're
congruent.
It gives you the radius.
This segment's congruent to itself. Usually gonna give us the radius, so we'll probably know that. We'll know that. We may even know one of these. If we know one of those, could we find this length?
Yes.
Yeah, by using Pythagorean theorem, all kinds of stuff that we know from that picture. Just knowing that it was a circle.
That's
On the worksheet, this, I don't think this is on your paper anywhere, and we're getting ready to get to the packet. Somebody tell me what you know about this angle right here. The right angle. Point of tangency, radius touches it, it's a right angle. How could we find what R is? Do we have Pythagorean's theorem? Let's see if we can use that. How long is the hypotenuse? Let's go there first. Is it just 6? It's r plus 6 or 6 plus r, right? So we gotta square that. How long is leg A? 9. How long is leg B? Now watch on this. Don't make these harder than it is. This looks confusing. And you guys already got confused because you had to do the 6 plus r thing there. Remember FOIL method? R plus 6 times r plus 6, correct? Here, what's 9 squared? And this is still r squared. R squared. Hopefully you can do some of this in your head. R times 6 is 6r. 6 times r. 6r and 6r give us 12r plus 36. If you remember FOIL from last year. Now, where most people get confused, like, oh crap, that means I gotta factor and do all that stuff. You got an r squared on this side, r squared on that side. Guess what's gonna happen with it? They cancel each other out. So now we're left with 81 equals 12r plus 36. Is that pretty easy to solve? What's that, 45? Somebody help me out. It's 45 divided by 12. Is that 40, is that right, 45? 45, I think. 3.75. So what's the radius of that circle? How long is this? 9.75. On the packet, look at the first page on the packet. We got just a couple of minutes. On that first page, if you remember back, we were doing problems and we left our answer as something like 3 times the square root of 2 instead of grabbing our calculator and doing the extra math. On this packet, pick me a problem on the first page. 4. 4's got 4 blanks on it, right? First one is the radius, second one's diameter, then circumference, and area, right? Sorry. So they give you the radius, what is it? 18 centimeters. Easy one to find. What's the diameter? 36 centimeters. Write that in there. Circumference. What was the formula for circumference? Diameter times pi. What'd you just tell me the diameter was?
36.
This is what I want you to do. Just like when we had this square root, instead of rounding off an answer and grabbing your calculator, just write 36 pi. That's the same thing. Now, if they want a decimal answer, then grab your calculator and change it to a decimal. All right? What's our units? Just centimeters, right? What's the formula for area of a circle? Pi times radius squared. What's the radius this time? Somebody help me out. What's 18 squared? 324?
Yes.
And we still got to times that by what? Guess what we're going to do? Just say 324 times pi. And leave it that way. That's an exact answer instead of rounding it off. What's our units?
Squared.
Centimeters squared. Is that first page going to be very difficult? Cooper didn't listen to anything I said there. He went ahead and he's punching it all into the calculator. Oh, I love you, Cooper. Goodness, I recorded that.